Hello, this is Ms. DB, and today we are going to go over the last section of Chapter 6 that we are going to cover. There are a couple more, but this is our last required assignment. And this is on investigating graphs of polynomial functions. So this is broken up into two parts. This video is about part 1, in which we are going to describe the graphs, and then in part 2 you'll actually graph these polynomial functions using Geometry Sketchpad. So our objectives today are to use properties of end behavior to analyze, describe, and graph polynomial functions. The other objective we will do in our next lesson. So remember that polynomial functions are classified by their degree. We talked about this in section 1. And the graphs of polynomial functions are also classified by their degree. Each graph, based on the degree, has a distinctive shape and characteristic. So we've been working with linear functions since pre-algebra. That has a degree of 1, like y equals 3x plus 2. A quadratic function, we covered those this semester, has a degree of 2, such as y equals 3x squared plus 0, something like that. A cubic function, now these we haven't looked at closely yet before, they have a degree of 3. They will either start low down and go up and then up again, or they can start up here and go down, up, down. So they'll turn twice. A quartic function has a degree of 4. It will turn 1, 2, 3 times. It'll either look like a W or an upside down W, roughly. And then a quintic function has a degree of 5. That will turn 4 times, 1, 2, 3, 4. Whoops, 1, 2, 3, 4. Yep, I got them all. And it will start either decreasing and increasing, or vice versa. And they will continue. You can have higher degree ones, but these are just the degrees of 1 through 5. When we talk about end behavior, we mean what's happening as the x values approach negative infinity and positive infinity. So in other words, what happens as they are approaching to the left and to the right, or to negative infinity and positive infinity. The degree and leading coefficient is a big key and will tell us what its end behavior is going to do. So this box right here is something that it's on your worksheet, but you will want to print this, have it handy, take a picture of it so you can keep referring back to it, something like that. And this tells us that if your polynomial, that's p of x, has a leading coefficient, a, the number in front of the first, when written in standard form, the a is greater than 0, then it's either going to be this or this. So if a is greater than 0, then as x approaches positive infinity, p of x also increases or approaches positive infinity. That's what this arrow means. It means approaches. And this is the sign for infinity. As x approaches negative infinity, that's on this end, you can see that the function also is decreasing, approaching negative infinity. In an even degree function, as x approaches negative infinity, as we move to the left, the function, the red line, is increasing and is going to keep going up to positive infinity. And as x increases and goes to positive infinity, the y value, the p of x, is also increasing and will go to positive infinity. So that's the two possibilities you could have if your first term is greater than 0. Let's look at what if it's less than 0. What if you have a negative in front of the leading term? Then what happens as x approaches negative infinity, your y value, your p of x, is increasing, and as x increases, goes to positive infinity, your p of x decreases, so it goes to negative infinity. And here's our other possibility. As x approaches negative infinity, to the left here, p of x is going to negative infinity, and that's when you have an even degree, like 2, 4, 6, like a quadratic. And as p of x approaches negative infinity, then it's also going to negative infinity. So this would be odd degrees. This would be like p of x is like an x cubed, or x to the 5th has an odd degree. Even degree is if it's like x to the 2nd or x to the 4th. And there'll be other stuff with it as well. Now, if you have a negative in front, that's when you would have this upside down u. That would be if you have like a negative x squared, or negative x to the 4th, or negative 3x squared. It doesn't just have to have, it can have a number in front of it. And this would be like, example would be negative, let's do 3x to the 3rd minus x plus 3. I'm just making up these. All right, let's look at some problems here. If we have to determine the end behavior of polynomial functions, so we are given a function, and we are supposed to determine the leading coefficient, which that's just the number in front of the first term when it's written in standard form, the degree, and the end behavior. So the leading coefficient is -1. If there's no number there, that's a 1, and it was a negative. We're supposed to say the degree of that. The degree is the exponent on the first term. That's an even degree. And now the end behavior. So remember, you can use this chart. Here we have a even degree. It was to the 4th, and it was a negative leading coefficient. So you say, okay, so I go down and I go across, and I have, this is my end behavior right there. So my end behavior is that the degree, that as it is x approaching negative infinity, p of x is also approaching negative infinity. And as x approaches positive infinity, p of x approaches negative infinity. In other words, you'll get something like this. Now, we don't know, we could graph it and see that it would look something like this. But that even before graphing it, we'll know that it looks like that. Okay, here's another example. P of x equals 2x to the 5th plus 6x to the 4th minus x plus 4. So we have to name the leading coefficient. That's easy enough. It's 2. The degree, that's easy enough. It's 5. And then the end behavior. So we have a is greater than 0, so it's a positive leading coefficient. And we have an odd degree. So that means as x approaches negative infinity, p of x also approaches negative infinity, and as x approaches positive infinity, p of x is positive infinity. So as x approaches negative infinity, it's going farther negative, and there's probably some turns, and then it's going to go positive as x approaches positive infinity. So something like that. All right, here's the problems from your worksheet. Now I copied the graph on here, the cheat sheet, so that we can use this to refer back to. So let's look at number 2. We have negative 9x to the 6th plus 2x to the 3rd minus x plus 7. So you have to name the leading term, which is negative 9x to the 6th. The leading coefficient of that is negative 9. So it has a negative leading coefficient. That's what this box is for. The sign is negative. The degree is 6. Even degree of 6. So it's an even degree and negative. We have to look at this box right, whoa. This box down here tells us what the end behavior will do. And then we're going to fill in the blanks. As x approaches negative infinity, p of x also approaches negative infinity. And as x approaches positive infinity, here's the positive infinity, p of x approaches negative infinity. Now, how are you going to write negative infinity when you're typing? And on these ones, you don't even have those little arrows. So let's look at the worksheet here. And just look at how you could do this in Word. Okay, so there's a couple different ways. One way is you could go to, let me make this worksheet a little smaller so you can see the top part. You could go to Insert, Symbol, And infinity is a symbol that is an option. Let's see if we can find it easily. Not so easily, right? I thought there'd be a math one. Special characters? No. So I'm sure it's here somewhere, but I can't find it quickly. But you could also, I highlighted that, and now I'm doing Control C, and when I do Control V, there's the infinity sign. So we said that as x approaches negative infinity, what was going to happen? The p of x, the graph, was also going to approach negative infinity. So I would just have to put a negative in front of this. So the easiest way is probably just to copy and paste the infinity symbol that is already here. Of course, you could also just write negative and then write the word infinity. Or INF is fine. So to make that little arrow, that's also tricky, but you can copy this arrow. So I could write as x approaches, I copied the arrow, or I could just write the word approaches. You can also make kind of an arrow by making the line, the dash, you know, the negative thing. Whoa, go away. And then putting a greater than sign after it. That's kind of a approaches. So 3 different ways to do approaches. And then what was I going to say? Infinity. And you can just write infinity if you want. Or you can try to copy and paste the infinity symbol. And then you could write, you know, you could just finish p of x. P of x. Approaches, that's what the arrow means. And then you would decide if it's negative infinity or positive infinity, depending on the problem. All right, I'm going to go back to the slideshow. So, oops. I hadn't filled this in yet. So as x approaches negative infinity for number 2, this would also approach negative infinity. Whoa, I got like double pen going. And as x approaches positive infinity, this would also approach negative infinity. What's happened to my pen here? So you just have to find the right box that is on this little chart. All right, the next thing we're going to talk about is when you look at a graph. And as well as doing the, you know, what's the positive or negative leading coefficient and what is its end behavior, we're also going to talk about what are its approximate zeros, which we can just look at the graph and find where is it crossing the x-axis. All right, so the end behavior, we can see that as x approaches negative infinity, this is approaching positive infinity. It's getting bigger and bigger and bigger. Also, as x approaches positive infinity, it's going to negative infinity. So we have to find the one that does this on the graph. So let's see which one, right here. As x approaches negative infinity, p of x approaches positive infinity. That matches, yep. And as x approaches positive infinity, p of x approaches negative infinity. Yes, this graph matches this graph. Now, not exactly, because it has more turning points. We can also see how many turning points it's going to have. So we know it's going to have odd degree leading coefficient less than 0. We could say that there are 1, 2, 3, 4 turning points. I know that this is going to be x to the 5th. Now, I don't know all the rest of it, but it's going to be x to the 5th because you will always have 1 degree more than how many turning points you have. So it's of odd degree with negative leading coefficient, so I'll put a negative in front of this. It might be a number. Also, let's look for the approximate zeros. The approximate zeros are where it's crossing the x-axis. So it crosses the x-axis at approximately here, and here, and here, here, and here. So there's 5 approximate zeros. The first one looks to be, if this is at -1, this would be -2, a little bit more than -2. So the approximate zeros, let's say negative 2.1. Now the next one is about right here. That's less than negative, it's between negative 1 and 0. So let's say negative 0.8. These are approximate, remember. And then the next one looks like it's right at 0. And then I've got one between 0 and 1. Looks like maybe 0.8. I don't know. And then the next one is just a little bit more than 2. Let's say this one's at 2.1. Now I don't know if it's really symmetric and would line up that nicely, but those are the approximate zeros. So you're just going to estimate where those might be crossing the x-axis, where your graph crosses. Okay, here's another example. So we have to find the graph that matches what's happening in this picture. So we can see that as our x approaches negative infinity, our function is going up. It's increasing, approaching positive infinity. And as x approaches positive infinity, it's also increasing and approaching positive infinity. So which one goes to positive infinity both times? And it's this one. It's an even degree with the leading coefficient greater than 0. Now we could get even more specific and say that this turns 1, 2, 3 times, which means that this is going to be x to the 4th. So our p of x is going to be something positive, x to the 4th, and then there might be a number in front of it. We don't know all the rest of it, but we can get a good start at what our function is going to be. And then we're also going to look at our approximate zeros, and our approximate zeros are where it crosses the x-axis, which it looks like there's 3 of them. There's one here, here, and here. So our approximate zeros are at negative, a little bit more than negative 1, maybe negative 1.25, I'll say. And there's one at 0, it looks like. And then there's another one at maybe 0.9. It's very close to 1. Let me erase that circle there. Very close to 1. Maybe it even is 1. It's hard to tell. And there's our, I think we said everything we needed to say about that. So on your worksheet, you're just going to do the same thing. You're going to be given a graph. You're going to analyze the graph in order to decide whether it has an odd or even degree and a positive or negative leading coefficient, and then name the approximate zeros. So this is number 6 from your worksheet. We can see that as x approaches negative infinity, the function is increasing to positive infinity. And as x approaches positive infinity, the function is decreasing to negative infinity. Looks a lot like this one down here. So we see that that matches. Also, we see that it will have then an odd degree, and it'll have a leading coefficient less than 0. It's a little bit hard to see the turning points on this one. I think there's 1, 2, 3, 4. I think this would be like a negative x to the 5th. Oops. But you don't have to say that on here. We'll just keep that in our mind. And then also the approximate zeros, it looks like it's at about negative 1.5. And then this, I think it's right at 0. And then this looks like maybe 1.3. And again, these are approximate. And I would have to zoom in to see if there's anything else going on in this little area. But it looks like it's crossing the x-axis 3 times. Okay, here's our last one. This is number 9 on the worksheet. So you need to say that, as x approaches negative infinity this way, it looks like the function is increasing to positive infinity. So as x approaches negative infinity, p of x approaches positive infinity. That happens in these 2 cases, but also as x approaches positive infinity, the function is also increasing, whereas in this one it's decreasing. So that rules that one out. But this one still matches. So it is an even degree with a leading coefficient of greater than 0. And then you are supposed to name the approximate zeros. So assuming that this is negative 1, negative 2, negative 3, the scale's not marked, it looks like we're crossing our x-axis at 0. And then again right here at maybe it's negative 0.75. They're all negatives after that point. And we've got one here. Yeah, that's close enough. And then this one right here would be like negative 1.3 maybe. I'm estimating, which is all you have to do. And then the last one would be between -2 and -3, maybe -2.75. These are estimates, so yours will be slightly different than mine. And if you graph this with technology, then you can zoom in, you can put a point there, you can measure the coordinates of that point, and you can find the exact zeros, or very, very close to the exact zeros. All right, so that's it for this lesson. In the next one, we will look at graphing these using technology and how to do it by hand, but that's a lot more complicated. All right, thanks a lot. Have a wonderful day. Let me know if you have any questions.